How are you, my friends? This is Calculus 1 solved questions, finding the derivatives of inverse trigonometric functions related to lecture 13b. Let's see question number 1. Y equals x times inverse tan of x minus ln of square root of 1 plus x squared. It's a nice function. Let's find the value of y prime at 1. So we need to find the derivative of the function, and then we evaluate that derivative at 1. Now we can use the chain rule for the derivative of inverse tan of u, which is 1 over 1 plus u squared times du over dx. First, here we see the product rule, x times the inverse tan of x, and this is the derivative of ln of this function. So we can use the product rule also, the derivative of the first times the second plus the derivative of the second times the first, which is x, minus the derivative of ln of this function u. It will be 1 over u times du over dx. This is from lecture number 12. Or we can say the derivative of ln of u, simply u prime over u. So this will be 1 plus x squared all to the power half. So it will be half times 2x divided by 1 plus x squared. Now let's simplify more. The derivative of x is 1. This one we leave it. The derivative of inverse tan of x is 1 over 1 plus x squared times the x, minus, we cancel the 2 here, minus x over 1 plus x squared. This will be cancelled, and then the answer will be, the derivative will be only inverse tan of x. So we replace 1 in the last derivative here. Y prime at 1 will be inverse tan at 1, which is pi over 4. Now, question number 2, we have the function y equals x times inverse sine of x plus x times inverse cosine of the x. Let's find x times the derivative of this function, dy over dx. So you find the derivative, multiply that by x, and then the answer will be either x or y or 0 or xy or x squared y. So here we have to apply the product rule twice for the first 2 functions and the second 2 functions. So let's start. dy over dx will be 1 times inverse sine of x plus 1 over square root of 1 minus x squared, the derivative of this inverse sine of x times the x, plus the same idea we can apply here for this product. And here we have the derivative of inverse cosine of u. And here we have only x. Let's simplify more. This is inverse sine of x. This is x over square root of 1 minus x squared. And this one will be plus inverse cosine of x plus this. Now we have a minus x over this plus x over the square root. We can cancel. What's left is inverse sine of x plus inverse cosine of x. Now remember the required. What do we need? X times the derivative. This is the derivative. So let's multiply it by x. X times the derivative, x times all this derivative will be exactly the function. You see? X inverse sine of x plus x inverse cosine of x will be y. So the answer is y. The choice is B. Question number 3 is not easy. Let's try it. Y equals inverse tan of b plus a cosine of x divided by a minus b cosine of x, where a and b are non-zero constants. They are real numbers and not 0. Find dy over dx. There is a heavy calculation in this question. Now we have inverse tan of all this. This is u. See, we have to use this chain rule here, the derivative of inverse tan of u, 1 over 1 plus u squared times the derivative of the u. Now be careful here. So y prime will be 1 over 1 plus all this quantity here, the argument here, all this quantity squared from u squared times the derivative of all this expression. See, this is numerator over the denominator. We have to find the derivative of that. So we have to use quotient rule, u prime v minus v prime u, all divided by v squared. Now, this one, 1 over 1 plus something over something squared. I can remind you of something in the algebra, 1 over 1 plus m over d squared. See, this is m squared over d squared. When you find the LCD, it will be d squared here, and then you multiply by the reciprocal, so it will be d squared over d squared plus m squared. Now be careful here, you can try it yourself, please. So now we have, this is the denominator here, a minus b cosine of x. It will be a minus b cosine of x squared, that's d squared, a minus b cosine of x squared plus, this is the m here, b plus a cosine of x all squared. So now we have to find the derivative by the quotient rule of this fraction here. So the derivative of the numerator times the denominator minus the derivative of the denominator times the numerator divided by the denominator squared. Now let's find one by one. B plus a cosine of x prime, it will be the derivative of b is 0, and the derivative will be minus a sine of x. Leave this one. See, there's a minus here between the two terms. Then the derivative will be minus of all this, which is minus b sine of x times that. So we have here 3 minuses. Be careful. Minus from the question, minus from the b, and minus from the derivative of cosine of x. Now we can continue on the next slide. What I can tell you here, what will happen, we can cancel all this with all this. You see, a minus b cosine of x squared, up and down, we can cancel it. You can see it here. Then we simplify more. On the numerator, we have minus a sine of x times a minus b cosine of x, and there is a 1 minus here because we have 3 minuses. Minus times minus b will be plus b sine of x, and there is 1 minus left. So minus in the bracket, b sine of x, and the last one will be b plus a cosine of x. Now we need to multiply in the numerator, and we have to expand in the denominator. So minus a squared sine of x, minus and minus, we have plus ab sine of x cosine of x, minus b sine of x times the b, minus b squared sine of x, minus b times a, so minus ab sine of x cosine of x. We can cancel also these two terms. In the denominator, we have a squared minus 2ab cosine of x plus b squared cosine squared of x. And this one we have b squared plus 2ab cosine of x plus a squared cosine squared of x. We can cancel also minus 2ab cosine of x plus 2ab cosine of x. In the numerator, we can take a common factor, minus here, and also sine of x. So inside the bracket, we will have a squared plus b squared. Now in the denominator, we have a squared plus b squared by itself, so we can leave it. And then we take cosine squared as a common factor. We have a squared plus b squared times cosine squared of x. So we can divide up and down by a squared plus b squared, the 3 terms together. Or you can take common factor a squared plus b squared from the denominator, then you can cancel. So what's left? The derivative minus sine of x divided by 1 plus cosine squared of x. There is no a and there is no b in the derivative of this nice function. Now, question number 4 is also nice. We have y equals x to the power inverse sine of x. Let's find y prime divided by y. Now, this type of function here, we have y equals x to the power inverse sine of x. We can use logarithmic differentiation. Let's take ln of both sides. So ln of y will be ln of all this. We can use the properties here of logarithms. So we can bring down inverse sine of x times ln of x. So we can use the product rule here. And then on the left side, we can use the chain rule. So ln of y, let's find the derivative, y prime over y. Inverse sine of x times ln of x, we can use the product rule, u prime v plus v prime u. So the derivative of the first is written here on the right side, 1 over 1 minus x squared times ln of x. The derivative of ln of x will be x prime over x, which is 1 over x times inverse sine of x. Just rearrange it here. So y prime over y will be ln of x divided by square root of 1 minus x squared plus inverse sine of x divided by x. That is the answer. Question number 5. Let's find the slope of the tangent line to the graph of this not easy function. Inverse sine of x all squared plus inverse sine of y all squared is equal to 5 pi squared over 36 at the point half, square root of 3 over 2. So this is x and this is y, and we need the slope. So first we have to find dy over dx, which is y prime. Then we replace x by half, y by square root of 3 over 2. So for sure we have to use implicit differentiation. Okay. So now let's use implicit differentiation. This is all power 2. So we can use also power rule. Bring 2 down. Inverse sine of x to the power 2 minus 1, which will be 1, times the derivative of this inside, inverse sine of x, plus the same thing for the y. But remember here, y is a function of x. So at the end, we have to multiply by dy over dx, which is y prime, equal. The derivative of this constant is 0. That's a number here on the right side. So derivative will be 0. Just simplify all this. 2 inverse sine of x times the derivative will be 1 over 1 minus x squared plus 2. This is also power 1. The derivative will be 1 over square root of 1 minus y squared times y prime. So let's solve for y prime. So you can do it yourself, y prime. This is what we need here. Y prime is dy over dx. So when you simplify this equation, you will get minus inverse sine of x times square root of 1 minus y squared divided by inverse sine of y times square root of 1 minus x squared. Okay, so we have, this is the slope formula now. We need the slope at this point, half square root of 3 over 2. So the slope is the derivative dy over dx, and then we can replace x by half. Every x, see there is x half here up, and there is another x is equal to half here. Y will be square root of 3 over 2 inside the square root, and we have inverse sine of square root of 3 over 2. Now, this is a minus, so we leave it. Inverse sine of half will be pi over 6. Inverse sine of square root of 3 over 2 will be pi over 3. And here you square the number 3 over 4, and there is 1 minus 3 over 4 will be the square root of 1 over 4. And this will be the square root of 3 over 4. This is heavy calculation, maybe. You can try it yourself. I said here it needs some calculations, please. You can try it yourself. When you simplify, the slope will be minus square root of 3 divided by 6. Question number 6 is not difficult. We have a function arc cosine of 1 over square root of x. Let's find only the derivative f prime of x. That's easy. Now we know our cosine of 1 over square root of x will be the same as inverse cosine of 1 over square root of x. So we have to use this formula for the derivative. Now also, we know that 1 over square root of x, this is 1 over x to the power half, so we can write it x to the power minus half. Now the derivative of this inverse cosine will be minus 1, sorry, it will be minus 1 divided by square root of 1 minus all this u, see u 1 over square root of x squared. This is u now, 1 over square root of x, times the derivative of this u, du over dx, which I mentioned here, x to the power minus half. So we can use the power rule here, minus half will come down, x to the power minus half, and then minus 1, which will make it minus 3 over 2. Just simplify here. Minus 1 times minus 1 will be plus 1. There is a 2 in the denominator. Here we can find the LCD. So it will be x minus 1 over x. We can have it into 2 radicals. And this is x to the power 3 over 2. Now we have the same base here, x to the power 3 over 2, x to the power half. So we can subtract 3 over 2 minus half, which will be 1. So the final derivative will be 1 over 2x. I mentioned here 2 times. You can write 2x square root of x minus 1 as an easy answer. Question number 7 again is not easy question. You can try it yourself if you want, and then you will see the details on the next maybe 2 slides. F of x will be 2 inverse sine of 3x. Let's find the derivative of the inverse at pi over 2. The derivative of the inverse at pi over 2. Now we know the formula. The derivative of the inverse at x will be 1 over f prime of f inverse of x. Now x in our question here is pi over 2. So what we need, the derivative of the inverse at pi over 2 will be 1 over f prime of f inverse of pi over 2. So this is what we need, the inside here. We don't have it. Okay, so this is what we need. F inverse at pi over 2. So I found it now in this rectangle here. So I said let f inverse of pi over 2 is equal to k. Let's just call it a k. So take f on both sides here. So pi over 2 will be f of k. F of k means I replace k in the function, in the given function. 2 inverse sine of 3k is equal pi over 2. Divide by 2 here, you get inverse sine of 3k is pi over 4. Now let's take the sine of both sides. So we get 3k is equal sine pi over 4. Sine pi over 4, we know this is a special angle. It will be square root of 2 over 2. To find k, divide by 3. So k will be square root of 2 divided by 6. Now this is what we need. F inverse of pi over 2 is equal to k. So f inverse of pi over 2 is equal to this k square root of 2 over 6. Now, let's go back to the required. We need the derivative of the inverse at pi over 2, which is 1 over f prime of f inverse of pi over 2. We have found this value in the inside the bracket here, which is square root of 2 over 6. So what we need now, f prime at this number. So we have to go to the function itself, the given function, find the derivative, and replace in the derivative every x by square root of 2 divided by 6. We will get the answer. So we have to continue on the next slide. Now, let's find the derivative f prime of x. The function is 2 inverse sine of 3x. So it will be, see 2 is a constant here, so we leave it 2. 1 over 1 minus u squared, 1 minus 3x squared times the derivative of the u, which is the derivative of 3x, which is 3, times this 2. will be 6 over square root of 1 minus 9x squared. So we replace x by square root of 2 over 6. So it will be 6 here in the numerator divided by big square root 1 minus 9. In the bracket we have square root of 2 over 6 all squared. Now, I did simplify all this. It will be 6 square root of 2, all this expression. Please try to do it to make sure you understand how we get 6 square root of 2. Now, what do we need? The derivative of the inverse of pi over 2, which is 1 over f prime of f inverse of pi over 2. This one we have found in the previous slide, square root of 2 over 6. The derivative here, f prime of this number will be 1 over 6 square root of 2 is the final answer. Now, question number 8 is really easy, maybe 1 line, 2 lines. F is one-to-one function such that f of 3 is equal to 7, f prime of 3 is equal to 0.5. Let's find the derivative of f inverse at 7. So easy. Now, by the definition, it will be 1 over f prime of f inverse of 7. We know f of 3 is equal to 7 given. Let's take the inverse on both sides. So 3 will be f inverse of 7. So directly, I can write f inverse of 7 as 3. And f prime of 3 is given also 0.5, which is half. 1 over half, then the answer is 2. Really easy question. Now, for more questions on inverse trigonometric functions, you can visit the Calculus 1 lectures, lecture number 13B, please. And for more questions in general for Calculus 1, you can see always Calculus 1 solve questions. Thank you for watching. If you like the video, you can subscribe and share it with your friends. I hope I can see you in another video with another topic. Thank you guys for listening.